Good morning, grade 9s. Welcome to today's mathematics lesson. My name is Rosa Mtimunya, and this lesson is proudly brought to you by the Gauteng Department of Education. Okay, so today we are going to continue with classifying 2D shapes, and we are focusing on the properties and definitions of triangles. So make sure you've got your ruler, your pencil, your workbooks, and your calculator in front of you before we start this lesson. All right. Okay, the lesson objectives for today. By the end of this lesson, you should be able to revise properties and definitions of triangles in terms of their sides and angles. And you should also be able to distinguish between equilateral triangles, isosceles triangles, as well as scalene triangles, okay? Your pre-knowledge from grade 7 and 8, that would be your types of triangles, your properties of triangles, as well as your constructions. You remember when you had to construct your triangles and your parallelograms, okay? This baseline activity, I'm going to give you 1 minute to answer the questions. You can either answer in class and raise your hand, and then also write it in your book, so when we mark it, you can give yourself a mark. All right, 1 minute for this activity. All right, grade 9s, I trust you're able to identify some of these symbols. So the first one here, the angle B, what does it represent? It's a right angle. Do you see that? Remember, a right angle is indicated with that tiny block or the L. All right. And then for B, what do the two arrows represent on these lines? These two arrows represent that AB is parallel to DC, okay? What you need to note is that even though AB is parallel to DC, they are not parallel to AD or BC, okay? And the next one, the two lines here that look like equal signs, those symbolize that AB is equal to, it has the same length as the side DC. Do you see that? But you need to note that it does not have the same length as AD or BC, okay? Right, so if you have this, you would get a mark for each of these questions. All right, remember we have a WhatsApp line on 0647488913. Do make sure you send us pictures of your work and ask us questions, okay? Start asking your questions now so that we can assist you as we go through the lesson and you're able to keep up with all the concepts we are discussing today. All right. Okay. Now, for this activity, I'm going to give you a further 1 minute, and then we'll come back and discuss it together. All right, grade 9s. I trust this was much easier because you now know what the symbols mean, right? Okay, so you're asked to name the two triangles that are here. For triangle A, you noticed, right, that the sides are all different lengths. Do you see that? Because these symbols, none of them are the same. Do you see that? Okay. So that type of triangle is called a scalene, if you remember from your previous grades, right? And then for B, do you see that these two symbols here are the same? And you also notice that it also has two angles that are also the same, right? So this type of triangle is called an isosceles triangle, all right? So well done if you got 5 out of 5 for those questions. Send me a picture. Let me see how you did with those ones, right? Let's discuss some of the terms you are going to use today. Okay, interior means inside. So interior angles are angles found on the inner side of a triangle, right? And then exterior would be talking about outside. Therefore, exterior angles are angles on the outer side of a shape, all right? You're going to see some of these words as we go into the lesson. Now let's discuss the types of triangles. Remember, your triangles are classified either by their largest angle or by their sides, okay? So let's start by reminding ourselves of the types of angles we've done before and then associate those angles with some of the triangles, okay? So if you remember an acute angle, right? An acute angle will be less than 90 degrees. You must remember that. It will be less than 90 degrees, okay? And that's how you would draw your acute angle. That's what it looks like, okay? So this arm here can move up or can move down or up, but just make sure it never reaches your 90 degrees, okay? Right. Now you remember that. Okay, now if you look at this triangle, it looks exactly like that. If you see here, your acute angles are there. Do you see them? All of them are acute. So what would we call this triangle? It would be called an acute triangle, okay? You can also say acute angled triangle. And what you need to note is that it will have 3 acute angles, okay? So all 3 of the angles will be less than 90 degrees each, all right? And just to remind yourself, you know small things are cute. This is a very tiny cute puppy. Therefore, when you think of small things that are cute, you'll be reminded of your acute triangle. All right. For the next one, we are going to discuss the right angle. We've just done this. You were able to identify your right angle in your baseline, right? So what does the right angle add up to? It is exactly 90 degrees. You know that, right? It's not less than or above. It's always exactly 90 degrees. So it's equal to 90 degrees. And that's what it looks like, okay? Now you need to remember to always look for the L or the block that is by the corner of your triangle. That's the only symbol you're looking for if you are given a diagram and no description of the diagram, okay? So look for the right angle symbol in your triangles, okay? And that's one of the examples for a right angled triangle. So now we know the name. And what do we know about it? It's that it will have one right angle, okay? And you just need to train your eye to be able to identify the right angle in whichever direction your triangle is facing. See, this one's facing down. The first one, the triangle was put upright in the correct position. So just train yourself to look for the right angle regardless of the direction your triangle is facing, okay? Now I have a question for you. Can you have more than one right angle in a triangle? I'd like for you to draw this triangle. If you think you can, please draw it and send it to me. Let me see what your response is on 064-748-8913. As we go along, we will find the answer to this question, all right? All right, now we are going to discuss the obtuse angle. Do you remember your obtuse angle? It's the one that is between 90 degrees and 180 degrees. Remember, 90 degrees is the right angle, so it's not equal to 90. It's just after 90 degrees, and it also is not equal to 180 degrees. It's just before 180 degrees, so it's between those two, and it looks like that. Do you see? It looks like a deck chair, you know, when you're relaxing there by the pool. That's what it looks like there. Okay, and there's our triangle with the angle there. Okay, so we would call it an obtuse triangle, and what you need to remember about it is that it will have one obtuse angle. A good way to remind yourself of an obtuse triangle is to think of a hanger. Okay, so the side with the obtuse angle will be where the top of your hanger will be. Okay, so just think of a hanger every time you want to identify your obtuse triangle. All right. Okay, right, we have three triangles here. Let me just put symbols for this one. All right. Okay, now they have symbols on all of them. Now, with these three, can you please name these triangles? Just raise your hand in class and name the three triangles. I think Tepo has answered the first question. All right. So the first triangle is called an isosceles triangle, right? And then what do we call the second one? It's called an equilateral triangle. And the last one, what do we call it? It's a scalene triangle. Well done if any of you were able to identify these triangles. Now let's discuss their properties, okay? With an isosceles triangle, what do we need to note? We note that they have these two symbols here. So those two sides have the same length, right? And also these two angles are also equal. So it will have two angles that are the same, or they'll have the same value, as well as the sides that are also equal. So two angles, two sides that are the same, right? Okay. Then an equilateral triangle, do you notice that all three of the sides have the same length? So all three of them are equal. And also all three angles are equal, right? Do you notice that? So it already gives you an idea of its properties, because equilateral tells you already that the sides are equal. All right. Okay. So all sides have the same length. So all sides have equal length, and all three angles will be the same. You need to remember the special case. All three angles will be equal to 60 degrees. Okay. Mostly in your exams, you will not be told that the triangle here has 60-degree angles. You just need to remember that an equilateral triangle has the angles inside will be 60 degrees, each of them. All right. Okay. Now with a scalene triangle, what do we notice? That none of the sides are the same, right? So none of them have the same length. And we also can tell that, okay, in that case, that means the angles will also be different, right? So it will have all the sides that are different, and it will also have different sizes for the angles, okay? Right. Now we are going to discuss theorems, and we're just going to discuss two of the many theorems that come with triangles, okay? The first one is the triangle sum theorem, all right? This is when you're told that interior angles of a triangle add up to 180 degrees, okay? What this means that all the angles inside this triangle here, the triangle ABC, they will add up to 180 degrees, which means that if you say angle A plus angle B plus angle C, you must get 180 degrees. And your reason could be angle sum in a triangle, or sum of angles in a triangle, or you can use interior angles of a triangle, okay? So you're welcome to use one of the reasons. You don't have to write all of them. Just choose one that you're comfortable with. And every time you add the interior angles, use your reason. All right. So in this lesson, we are going to try and vary the reason so that you can memorize or remember most of them. All right. Okay. Now, the next theorem is the exterior angle theorem. Remember, we used interior for inside. Now we're using exterior for the angles outside the triangle. Right. So we are told the exterior angle of a triangle is equal to the sum of the interior opposite angles. This sounds like big English, doesn't it? What it means is that the angle here, angle ACD, do you see angle ACD is my blue angle? It's equal to the sum of angle A and angle B. Do you see that? Yes, that's all it means. All right. So you need to look for that. And your exterior angle of a triangle here, you need to be careful and make sure that it forms a straight angle here. Okay, it forms a straight angle on your triangle. All right, so it must form a straight angle there, and then you know that it's an exterior angle of the triangle. Okay, right, and that's the reason you use exterior angle of a triangle. All right, okay, now let's investigate a bit about the sum of the angles inside a triangle. All right, we're given a triangle here, triangle ABC, and it has all the angles. We can call this blue angle angle C, but they are color coded, so you'll be able to notice them. Right, now the first thing we are going to do is to construct a line. Okay, and that line will be parallel to AB, so we'll call this line, so we've just added a line here and added a point, so we call it CD. Do you see that? Okay, you've got it in your books, right? Okay, I don't want to talk alone. Somebody must be writing something here. All right, right. So we've constructed our line AB, and it's parallel to CD. Do you see now that AC is now your transversal because it's cutting through your lines AB and CD, right? Therefore, that means that angle A there would be equal to that angle that is formed at C. So those two angles are alternate angles. You remember your fun? So those two are alternate angles, and therefore they are equal. You know that, right? You know alternating angles are equal if the transversal cuts through parallel lines, right? Okay. What other relationship do you see here? You've got your parallel lines. You've identified them. What other relationship do you see? I trust you notice that there's a corresponding angle relationship here between the angle B and this angle there, right? So B there would be equal to the angle at the bottom, and those two angles would also be equal. Do you notice that? So we've basically taken the two angles inside the triangle and moved them outside of our triangle. Now what you need to notice is that all three, angle A, B, and angle C, are now on a straight line. And now remember, with your straight angles of a straight line, they add up to 180 degrees, right? Do you understand how we came to say that the interior angles of a triangle add up to 180 degrees? All right, okay, let me give you 1 minute to quickly copy this diagram and understand it, and then we'll come back and continue the lesson. All right, welcome back, grade 9s. Remember, if you have questions, send them on 0647488913. I hope you now understand this part. Okay, we are not going to apply it. We are not going to ask you to do this investigation, but we will apply the results that we found from this investigation. Okay. Okay. Now, with this example, you're asked to calculate the angle A, and you're given a triangle with the 65 degrees there, and let's just name our triangle A, B, and C. Oh, wait, that now looks wrong. Maybe that should have been A. But the point is, you're asked to find angle A there. All right. Okay. Right. Let me just clean up so that you don't get confused. Okay. All right. Now, what would you do first? You'd have to remind yourself that all the angles inside this triangle are inside the triangle, right? So you're working with your interior angle sum, and your interior angle sum says that these three angles must add up to 180 degrees. Therefore, Your right angle is 90 degrees plus the 65 degrees plus the A must give you 180 degrees, okay? And what would be your reason for this? You choose one of the three reasons. So here I have angle sum in a triangle, okay? You choose one of the three reasons we gave you with that one, okay? And then you just collect your like terms here. I know there's a short way for doing this. I am doing this long method so that you are able to understand where we are getting all the values we are using, all right? But if you understand the short method where you start by just subtracting the two angles from 180 degrees, that is also a very good thing, and I will appreciate if you still use it. I don't have a problem, all right? Okay, now we subtract 155 degrees from both sides. You remember your rules of equations. With that, you know 155 degrees minus 155 degrees will give you a 0. And on the left, you're just going to have angle A. On the right, angle A will be equal to 25 degrees. Okay, right. I trust you have this. Okay, the next one. Okay. Now with this one, you're asked to calculate angles A, B, and C. I'm just going to give you 30 seconds to try it, to just try the first few steps of this example, and then we are going to do it together. Are you getting there? All right. Remember, if you have questions, send them on 064-748-8913. All right. Okay. Let's start the first part of this question. Your statement here, you still use your interior angle sum. So angle A plus angle B plus angle C will be equal to 180 degrees. But did you notice what type of triangle this is? Okay, if you did, you would know that it's an equilateral triangle, right? Which means that the three angles, angle A, angle B, and angle C, they are equal to each other. You remember that? And what's their value? Their value is 60 degrees. But now mathematically what you would have done, you would have taken 180 degrees and divided it by the number of the angles inside the triangle, that is 3, and that's where your 60 degrees would have come from. All right, therefore angle A is equal to 60, angle B is equal to 60 degrees, as well as angle C is equal to 60 degrees. Okay, so just always look at the symbols given on your triangles so you can maybe identify that some of these questions, as much as it says calculate, the calculations are going to be quite relatively easy because you already know what your solution is to that question. All right. Okay. Now we are going to work through this together. All right. Here it says if HG is equal to HK, right? Which two angles are equal? So we have a diagram here. It's been labeled for us. Now let's identify the equal sides because we are given two equal sides here. The first one is HG and the second one is HK, right? Now we've identified them. What type of triangle is this? Yes, it's an isosceles triangle. And what do you remember about an isosceles triangle? The opposite angles, the sides opposite the equal, the angles opposite the equal sides will be equal to each other, right? So angle HGK, do you see angle HGK? So this angle here will be equal to angle HKG, which is this angle there. Okay, I'll mark them for you again. And your reason would be angles opposite equal sides, right? So those two angles are equal to each other, right? And then the next one, we are given two angles that are equal, and then we are asked which two lines will be equal, right? Let's see. So we have angle KHJ. So which one is KHJ? Remember your angle here, it's the one in the middle. So just look, always just be careful and check that your angle is the one in the middle. So your H is in the middle. So you're working with the angle at the top. and then KJ, so you're working with this angle there. All right. And those two, we are told they're equal, so I've made them the same color, right? Now, which sides are equal? You're welcome to raise your hand in class and answer. All right. It would be the line HK and JK. Those two lines are equal, and your reason would be sides that are opposite equal angles, right? Remember, so you can be given a question where you are told that two angles are equal, right? So if you are told that, just remember that that means the opposite sides, those angles will be equal, right? Okay, I've just indicated that they're equal, and you see we're still getting an isosceles triangle. Okay, we're going to work with this example. I'm just going to ask you to try and work ahead of me as usual when we do our examples, right? So just you can start this example, and then as I go along, we'll be marking your work as well. Right. Remember to always use statement and reason, okay? Now, with this triangle, you are given 15 degrees, 27 degrees, and you're asked to find angle A, right? Okay. What do we do now? We have to use our interior angle sum theorem and say 15 degrees plus 27 degrees plus the angle A, they must give us 180 degrees. Do you have the statement? Well done. If you do, that's a good job. Now, what is your reason? Okay, you've got three reasons to choose from, and I have angle sum in a triangle. You could have written interior angles of a triangle, whichever reason you are able to use comfortably. All right. From here, you just collect your like terms, and you're going to have 15 degrees plus 27 degrees giving you 42 degrees plus the angle A, right? Those must be equal to 180 degrees. The next thing is to identify your additive inverse and subtract 42 degrees on the left hand side and on the right hand side. Once you've done that, on the left hand side, you'll be left with angle A being equal to 138 degrees. Now you can just be sure that, okay, you did this correctly, because do you see there, you've got your hanger. Do you see your hanger? Yes, so angle A is meant to be an obtuse angle. And if you remember with your obtuse angle, the angle must be more than 90 degrees. 138 degrees is more than 90 degrees, but it must also be less than 180 degrees. This is still less than 180 degrees, which means that you could definitely be correct in an exam. But for this case, we are definitely correct. Okay, right. Now, for this example, you're asked to determine x, and you're given two angles at A and angle at C. Right, do you see those? And x, if you've noticed, is on the outside of your triangle. Right. Okay. So are you trying it? Please do attempt this question on your own first so that we can work through it. I'll give you 1 minute to attempt it, and then we'll come back and do it together. Okay, grade 9s, remember we have a WhatsApp line 0647488913. Do send us pictures of all your work. Ask us questions if you have any. All right, I have a question from Landulwazi about how we identify corresponding angles. I know we are doing triangles today, but I'll just remind you too, when you're working with parallel lines, you're always working with F, U, and N. Okay, and your corresponding angles are formed when they give you the F shape, and those are the two angles below the arms of your F. All right, and remember those two angles are equal. All right, I don't want to go through all of this, but remember that your co-interior angles will add up to 180 degrees, and these angles here are alternating angles. Therefore, you must remember they are equal. I hope your memory has been jogged now that you see we were working with fun when we did that question. All right. Okay. Now, let's come back to this example that we have here. It says determine X, and you've been given angles at A and angles at B, and those angles are 60 degrees each. All right. So for the fun of it, you could have noticed that angles like this are giving you an isosceles triangle. Do you see that? And you actually do notice that if you were to do the maths here, this angle would also be 60 degrees, which would make this an equilateral triangle. All right, that's just an investigation. You need to train your eye to notice these things. All right, so to find angle X, what are we going to say? We are going to say angle X is equal to the two interior angles that are opposite angle X, and those angles are angle BAC, which is this angle here, as well as ACB, which is that angle there. All right, remember we are using our exterior angle sum theorem. All right, and from there you'd give your reason as exterior angles of a triangle, and from here you substitute the values that you were given for these two angles, and X would be equal to 120 degrees. Well done if you have that. Good job. Okay. Right. Now we have a classwork activity. I'm going to give you 2 minutes to answer the first triangle here. Okay, for A, because they have A, B, C. So for A, you're going to have 2 minutes. You're welcome to do all of them if you'd like. And then we are going to work on each of them as we go along. All right. So 2 minutes for A. Welcome back, grade 9s. Remember, if you have questions, send them on 0647488913. Buhlebe Zulu Secondary School, well done for sending us your work. I am loving the type of work you are presenting. Please keep your work as neat as it is, and well done for interacting with us. All right. Okay, so for angle A here, you were asked to find angle A given the two angles there at 30 degrees and at 80 degrees. Do you see those angles? Okay, let's work it on it. So all three angles are inside. So we are using our interior angle sum theorem. Therefore, we are going to add the three angles, right? And our reason would be that these angles are interior angles of a triangle. Remember, when you add them, their sum must be 180 degrees. Right, you have this, right? Okay. From here, you would collect your like terms, and you'd have 110 degrees plus angle A will be equal to 180 degrees, okay? What happens now? You have to isolate your angle A, so you would subtract 110 degrees on the left and 110 degrees on the right. On the left, you'll be left with angle A is equal to, on the right, 70 degrees. Do you have the solution? If you do, well done. Those are your marks. Okay, right. Now you know what to do, right? I'm going to give you 1 minute to attempt for angle B, all right? So please, 1 minute for this question. All right, grade 9s. This was much quicker, wasn't it? Because now you know exactly what theorem to apply, right? Okay, let's see how you did. So did you notice that angle B is inside and the two other angles that are given are also inside the triangle, right? Okay, so your interior angle theorem is what you are going to use, and that is at 41 degrees plus 54 degrees plus angle B. Those three must give you 180 degrees, right? And your reason would still be interior angles of a triangle. You could have used any of the other three reasons given. All right. Okay. From here, you collect your like terms. And then you are now going to use the 95 degrees and subtract it on the left and subtract it also on the right. And on the left, 95 degrees minus 95 degrees will give you a 0. And on the right, 180 degrees minus 95 will give you 85. Therefore, angle B is equal to 85 degrees. Do you have all of this? If you do, well done, good job. Okay, don't worry about the method we used, as long as you made sure that if you started by subtracting the two angles from 180 degrees, your solution still gave you B as equal to 85. That will be okay, all right? But you definitely need to show steps, and you need to have the correct reason there as well. Right, I have a question about from WhatsApp that says, do the angles change when it's exterior? So I think here what you were trying to understand was, why are we not equating the angles to 180 degrees? Remember, when the angle is outside, so let's just use this example quickly. When we are given this angle here and it's called X, it's outside the triangle, right? We don't equate it to 180 degrees because only the angles inside are 180 degrees. But we say this angle X is equal to these two here. It's equal to those opposite there, okay? So that's what we use when we're using exterior angles of a triangle. Okay. All right. I hope you were answered on that question. Thank you very much for sending that question to WhatsApp. Remember, our line is 0647488913. Okay. For this one, for this question, I'm going to give you 2 minutes. And then once you're done, we are going to do the solution. Okay, grade nines, I see some of you have questions about how we are applying the interior sum here for the angles, right? So I'll just work slower on this one so that you're able to catch up. Thank you very much for asking that question. I know maybe you were just panicked because you saw all three questions at the same time. So this one, we're just working with one triangle, right? So let's take it slow and work through it. That way you'll be able to understand how we came to the solutions for the first triangle when we were calculating A, and how we came to the second solution when we're calculating angle B. Okay, so the concept is the same. All right, so pay attention if you are the one who sent me this question. All right. Okay, the first thing you need to notice is the position of your angles. All right, are they inside the triangle or outside the triangle? They are all inside the triangle, right? So you are working with your interior angle sum theorem, okay? And that means the three angles inside the triangle, they must be equal to 180 degrees, right? Now you write that statement in mathematical form, and that statement in mathematical form will be 62 degrees plus 34 degrees plus the angle C is equal to 180 degrees. Okay, and then you give a reason for that. Okay, my reason is interior angles of a triangle. Okay, you could have used angle sum in a triangle. You're welcome to choose one of the three reasons. Please don't feel restricted to the one I am using. Okay, now what happens here? Remember, you're looking for angle C, right? So you need to make sure that angle C is on its own on the left. So we have to add those two. So we collect our like terms first. Okay, once we've collected our like terms, what do we do next? We notice that 96 degrees is positive, so we are going to subtract it on both sides by using its additive inverse. So now we've subtracted 96 degrees on the left and 96 degrees on the right. What do we have? On the left hand side, these two will give you a 0, so you'll be left with just angle C. Do you see that? Okay. And then on the right hand side, you have 180 degrees minus 96 degrees, and what will that give you? It gives you 84. And this is your solution. That's it. Okay, do you see now? I hope you were answered in that question. Please remember, if you have questions, send us questions on 0647488913. We also appreciate to see some of the work that you're sending us, all right? Okay, now with this classwork activity, I am going to give you 4 minutes to attempt it, and then we'll come back and work on it together. All right, grade 9s. I'm very happy. I'm seeing that you're doing your work. Maritime SOS, well done. I see that you are actually attempting this activity, and I love that you are using the correct statement and reason. All right. Okay, so let's start working on this solution. All right. The instruction was determine B. So it's part 2 of the same activity that we've just done. Okay. And we start here by saying we have to use our statement and reason. Have you analyzed your diagram? You've looked at your diagram. Did you see that you have 2 triangles in this diagram? One of the triangles is triangle ABD, and the other one is triangle CDE. Do you see that? Okay. Now, let's work. Remember, we start with what we know, which is the information given, and we find relationships between the information given and what we are looking for, right? So here, you should have noticed that the angle BCE forms a right angle with angle ECD. Do you see that? All right. And you give your reason as these two are adjacent angles on a straight line, right? And from here, you substitute the given value for angle BCE, and that's 160 degrees, plus DCE would give you 180 degrees, right? Because they're angles on a straight line. So those two, when you add them, they must give you 180 degrees. Now, from here, you just isolate your angle that you're looking for. Okay, there. You've done that. You subtracted 160 degrees on the left, and you did it also on the right. Do you see that? And that leaves you with DCE being equal to 20 degrees. And now, what do you do with this 20 degrees? You have to make sure you indicate it on your diagram, okay? The more information you have on every diagram that is given, the easier it will be for you to work towards the solution. All right. Okay, now we have that. What else do we notice on this diagram? Did you notice that the triangle CDE is actually an isosceles triangle? Yes. So because it's an isosceles triangle, you can write mathematically and say that the angle DCE, which is this angle that we already have found, is equal to this angle here. Okay, remember this side and that angle, this side and that angle. Remember, angles opposite equal sides, right? So angle DCE is equal to angle CDE. So the vertices at D, right? Do you see that? Okay. Those two are equal, and your reason would be angles opposite equal sides, right? Okay, you have that one. Good. If you have this, well done. So far, you're keeping up. I love it. Now, what happens next? The next thing is for you to now just make sure you state what value that is and then put it on your diagram. So now those two angles are equal, and now it looks like an isosceles triangle because the two angles opposite the equal sides are also equal. Do you notice that? Right. But now the question is, did you actually determine B when you were doing all these steps? Have you found B yet? No. All right. You haven't found B. You've just found information that will be able to assist you to determine B. So what do you do now? The next thing here would be for you to do what? I think I need to give you time to do it in your books. What do you think? So I'm going to wait here. I'll stand here, and then you are going, if you know you've made an error in the previous steps, please attempt it now and correct your error and solve and find angle B, please. Do you have the first step to finding angle B? All right, let's see if you do. So what you should have noticed was that angle B is actually in the big triangle, which is triangle ABD. I've highlighted it for you so you can see that we've moved on to the triangle CDE, right? Now, when you are working with this big triangle, you notice that angle B is inside the triangle. Do you see that? Okay. Therefore, you use your interior angle sum theorem, and that means you're going to add angle B and angle A as well as angle D, which is 20 degrees. You're going to add all three of those, and they must give you 180 degrees. Okay, so we have angle A plus angle B plus angle D is equal to 180 degrees, and our reason is interior angles of a triangle, right? What do we do next? From here, we substitute the values that we know for the angles, right? So we are aware that angle A is actually a right angle, so it's equal to 90 degrees, right? So we substitute it in, and then angle D there is 20 degrees. I've also substituted that in, and I left angle B because that's what I'm trying to find. Okay, from here you just add 90 and 20 degrees and you have 110 degrees. Okay, with the next step, what do? You subtract 110 degrees on the left, and you also subtract 110 degrees on the right. You have that step. I love that you're keeping up. That's a good thing. Well done. So from here, you now have angle B on the left. Remember, 110 minus 110 will give you 0. So on the right, what's the value you got for angle B? Angle B is equal to 70 degrees. Do you have this? All right, let me give you 30 seconds just to copy the final solution, and then we are going to continue. Okay, you have all of this? Okay, good. All right. Right. Okay. Now with this homework activity, please don't send me questions about it on WhatsApp, all right? But I am giving you 2 minutes to copy it, and then we'll come back and check on what you have on WhatsApp as well as do our summary, okay? Okay, grade 9s, I trust you're able to copy this homework. All right, now I'm just going to check what questions you have on WhatsApp, but we've mostly answered most of your questions and I have already seen most of your work. But let's just check if anybody else has a question, and then we're going to quickly go through it and then do our summary, okay? All right, let's see what we have. Okay, I have a question here. It says, how do you determine B if there's a big triangle that has a right angle? Okay, so for this question, I think we will have to go back to our slide with the big triangle, which is part of activity number 2. All right. Okay, let's see if we have anything else. Okay, all right, for now that's all we have, so let's just go back to our slide. Okay, right, now remember with the triangle that we were given, we had this triangle here. Okay, and there was angle B, right? And you had a right angle at this point, and you had also had to find, remember there was a triangle going on here, right? And this triangle was an isosceles like that, right? You see that? I don't want to use huge angle names here, that's why I'm leaving it plain so you can understand. And this angle here was 160 degrees. You remember that? So to find the angle B there, which is in the big triangle, you first had to use the information you are given, which is 160 degrees, to find this small angle here. Do you see that? Which was angle D. All right. So for that, you would have had to first find one of the angles, and that was point C. So you would have had to first find the angle there, okay? And if you notice, do you see this is a Y shape? Do you notice that this is a Y shape? Do you notice that? Remember, when you're working with Y, which is your intersecting lines, you're working with angles in a straight line. And that's how we came to use 160 degrees plus the angle we were looking for here must give us 180 degrees, right? And from there, you notice that 180 degrees minus 160 degrees will give you 20 degrees. And from here, you have 20 degrees, 20 degrees. So, because remember, if this is 20, that is also 20. The sides are equal, so the angles opposite those equal sides will be 20 degrees. From here, all you do is just add the 3 angles. So angle B plus this 20 degrees plus this 90 degrees must give you 180 degrees. And I trust from there, you definitely will be able to apply your interior angle sum. All right, now let's work to our summary. Okay, remember our types of triangles were divided by equal sides or largest angle. So with equal sides, we're working with equilateral triangles, isosceles triangle, and a scalene triangle. Right, in an equilateral triangle, you need to remember that all 3 sides are equal and all the angles inside each of them is 60 degrees. In an isosceles triangle, you need to remember only 2 of the sides will be equal, and it will also have 2 angles that are equal. All right, a scalene triangle, none of the sides will be equal and none of the angles are equal. Okay. Now, when we classify our angles by largest angle, our triangles by largest angle, we get an acute triangle, a right angle triangle, and an obtuse angle triangle. So in an acute triangle, we said it will have 3 acute angles. A right angle triangle has only 1 right angle. Remember, I asked you that question. You can only have 1 right angle in a triangle. And then in the last one, an obtuse triangle has 1 obtuse angle. And that angle will be between 90 degrees and 180 degrees. Okay. With your theorems, remember we use the triangle sum theorem. That's interior angles of a triangle add up to 180 degrees. As well as this exterior angle theorem. That's when we said when you're given a triangle, an angle outside, it will be equal to the sum of the 2 angles opposite on the opposite side inside the triangle. Right. Okay. In the next lesson, now that we know how to classify our triangles, we are just going to investigate the angles in a triangle. Okay, please remember to click the complete button at the bottom of the screen once this lesson is over. And thank you so much for joining us today. My name is Rosum Timunya. This lesson was proudly brought to you by the Gauteng Department of Education. Please remember to wear your mask, sanitize, and keep social distancing.